We'll begin our work with Chapter 2, Section 2A on working with units. So I've got some objectives listed here: principles of unit analysis, unit conversion, unit systems, and some currency conversions. So looking at unit analysis first, we need to realize that someone just wrote the number 4. 4 in itself has no meaning. There needs to be something attached to the 4 to give it some context, some understanding, some meaning to 4 of what. Okay, so when we're working in this, actually throughout the whole semester, anytime you write a number, there needs to be some sort of unit associated with that number. So I don't want any naked numbers. This is what we call a naked number. We don't want any numbers that don't have units. Okay, so just a couple of definitions. The unit is the quantity, describes what's being measured or counted. And unit analysis is the process of working with units to. So let's take a look at some keywords or symbols we'll want to recognize to help us interpret some of these math problems. So the word per, keep in mind, means division, like miles per hour just means you divide the miles by the hours. If we see the word or read the word of, it indicates a multiplication, and then sometimes in units we might have those units in terms of like kilowatt hours. A hyphen means multiplication, that those units were multiplied. If we're going to square something, we're just raising it to the second power. We'll be dealing with units of area, so foot times foot is a foot squared, feet squared, maybe that's a little bit better way of putting that. Cube means we'll be raising an item, a unit, to the third power, such as cubic feet or feet cubed when we're dealing with volume. So again, just working with units. It's important that you are able to work with fractions, so if you need a review on that, you can go to page 72 if your fraction skills are rusty. So let's take a look at example 1. So the situation is, suppose I drove 150 miles in 2 hours. What I would like to do is find my rate in miles per hour. And so that per indicates, as we mentioned earlier, there's a division. So if I do a division here of miles, which is 150, divided by, in this case, 2 hours, then I would come up with a unit in miles per hour. So if I just take the 150 and divide it by 2, that tells me I was traveling at 75 miles, and we can write this as miles per hour, or we can write this as 75 miles on the top and then hours on the bottom. Either way. So what about example 2? Again, we're working with the units here. The math is going to be simple. We're just kind of working our way around some common unit conversions. So suppose I purchased 6 pounds of nectarines at a price of $1.68 per pound. How could I find my total cost? Well, I'm sure you're looking at this and saying, okay, I'm just going to multiply. But I want to emphasize the work with the units. So I know I'm multiplying 6 times 168, but let's look at this with the units. So it would be 6 pounds times $1.68 per, meaning division, pound. And when we're working with a unit analysis, we think of both of these as fractions. So this is like 6 pounds over the number 1. And what we want to notice is in unit analysis, we want certain units to cancel out. And what I would see is that pounds would cancel with pounds because they're across from each other, just doing that cross canceling. And when I do that, notice the only unit I'm left with is dollars. And that's what I was wanting to find, my total cost in dollars. So you knew to multiply the 6 times the 168. The deal is I want to emphasize again those units. So the multiplication gives me $10.08, and the unit is in cost, and that's what I was looking for there. Now, actually, you can just disregard any of these guys that say video on the note sheets. Don't worry about that. But let's take a look at this one again, emphasizing the units. How much will you earn working for 6 months at a salary of $3,200 per month? So I know I'm going to multiply 6 times 3,200, not a problem. But with the units, this is 6 months. And remember, it's like a fraction over 1. And we'd be multiplying that by $3,200. And per means I'm dividing by month. And again, I see that these guys are in a numerator-denominator position, so I can cancel out those units, and I'm left with my unit of dollars, which is what I was looking for. And so now I'm just going to multiply 6 times the 3,200. When we multiply, we get 19,200. Again, not very sophisticated math, but we're going somewhere with this, working with the unit analysis. Okay, something that you'll need to know that'll come up throughout the work that we do are the concepts of area and volume and perimeter. And I need you to know the formulas when we're working with rectangles or cubes or squares. And you also need to know those basic US units of inches, feet, and yards, and probably miles too. We'll talk about that. So looking at the two figures below, one is a two-dimensional figure, one is a three-dimensional figure. So the question is, of these two figures, which one would I be working with area specifically? Well, given this two-dimensional figure, I would want to find the area of this figure. Area is in 2 dimensions. This figure, I have a third dimension, and volume is the capacity, how much would fit inside there. And so I will be looking at the volume for this particular figure. So let's suppose area of the figure A has the dimensions of 3 centimeters and 18 centimeters. And the question is, could I find the area? Well, let's just remember some formulas. The area for a square or a rectangle, I'm sure you know this, just reminding you, it's length times width. And the volume of this rectangular solid, I'll just say rectangular solid, is, I'm sure you know, length times width times that third dimension, which is height. So area has 2 dimensions, volume has 3 dimensions, and one more thing, let's go back to figure A. What about the perimeter? The perimeter of any figure, and here we're working with just squares and cubes, the perimeter is just the distance around that figure. So there's an actual formula. We can say that it's twice the length plus twice the width, but really all you're doing is adding up all 4 sides or all 6 sides, whatever the figure happens to be. So just a quick check on that. All right, so back to the area. So the area of this particular figure would just be length times width. I'll just put it right here, length times width, which would be 3 times 18. And actually, let me put those units on there because that's what we're trying to emphasize. So it would be 3 centimeters times 18 centimeters. You know the drill. Okay, so let's find that value. So we get 54 centimeters, but it's not just centimeters. It's centimeters, just emphasizing units again, it's squared because we multiplied a centimeter times a centimeter, so we have to make sure that that unit is in square units because we're dealing with area. So with area, we have square units. Area of any figure will always be in square units. So now let's give some dimensions to this rectangular solid. So we've got 8 inches by 4 inches by 3 inches. So I'll say this is 8 inches. I'll call this one 4 inches and this one 3 inches. And for the volume, we know for a rectangular solid, it's length times width times height. So L times W times H. Emphasizing the units here, 8 inches times 3 inches times 4 inches. So that will give us the volume of that figure in cubic inches. So that gives us a volume of 96 cubic inches. Remember, you've got to have a unit on your number. You've got to state that unit. All right, let's go back to figure B. And here's an interesting geometry question for that one. Look at the smallest face of that rectangle and find the area of the smallest face. And this is what we mean. Okay, this is a face. I've got a face of my rectangle here. And then I've got this face. And this particular face would be the same all the way around those 4 sides, and then these 2 sides on either end would be the same. So the question is, of those 6 faces, basically like a die, which one would have the smallest area? Well, it makes sense if you see it. This face is going to have the smallest area. How would I find the area of that face of that particular figure? Well, area is just length times width, because if we look at that, that's just a square. And my units are 4 times 3, so 4 inches times 3 inches. And I'd say the smallest face of that particular figure would have an area of 12 square inches. So as we mentioned, the unit of area is in square units, because we have 2 dimensions, and the unit of volume is cubic units, because we have 3 dimensions. Again, just skip what it says here on the video, don't worry about that, but let's take a look at this next figure. Let's put a little geometry into use. So we've got a raised flower bed. It's 25 feet long, 8 feet wide, 1.5 feet deep. We want to find the area of that bed and then the volume that it'll hold. So just a very elementary picture of what this might look like. We've got a flower bed, 25 feet long, 8 feet wide, 1.5 feet deep. So let's just add some units to this. So I'll say this is the 25 feet. Then I'll say that this is 8 feet. And then this height here is 1.5 feet. So the area. What dimensions am I going to work with for the area? The 2.5, the 8, the 1.5. I've got those 3. So for the area, I know this is a rectangular solid, so it's length times width, but do I use the 25 and the 8, the 25 and the 1.5, or the 8 and the 1.5? Well, since I want the area of this thing, this part is my area, then I'm going to use the 25 and the 8. So 25 feet times the 8 feet would give me quickly, oh, I should know that. Yeah, 200. 200 square feet. So that gives me the area of the bed. Now the volume incorporates all 3 of those. So length times width times height, which gives me all 3, and let me just be consistent with my colors here, 25 times 8 times 1.5. Square units on the area, and I'll have 300 cubic feet on the volume. Think about this. I mean, this is a problem that someone who is interested in gardening might come across, where, hey, they're working on a flower bed or a garden area. They need to fill this with soil. And so I would need to know the volume of that particular bed to determine how much soil or compost or whatever it is that I wanted to put into it. Unfortunately, or fortunately, whatever way you want to look at it, When you buy those types of items, it doesn't come in cubic feet. It comes in cubic yards. So we'll talk about how we'll do some converting of units in terms of something that we can actually compare and go out and purchase.